from fourth year computer engineering. Today my topic is AI lenses. So now let's get started. We humans have a natural talent. By looking in that photo, we can say that that is a girl with the sunglasses and a glass in her hand. And I am curious that can machine do that? Can machine analyze those photos like us? In 1950, a computer scientist named Alan Turing published a paper on computing machineries and intelligence, in which he described how intelligence can be created and how to test those intelligence. And in 1980, two scientists popularized the term deep learning, which means a computer can learn like a human. So this try to create a system to recognize an apple in any photos. So we have a photo, and it's like teaching a child. You just say child, this is an apple, and eventually he will learn that that is an apple. And we do the same step to teach a computer. We provide a large set of images to teach any system so that it can recognize apple in other photos. So our main goal from that training is to create a function like that. And in that ABEF shown in red is some parameters that we can obtain from image, and that WXYZ are the parameters that we are going to obtain from our training. And let's assume S equal to 70. So first we provide a large set of images, and for each images the system will divide into partitions. In reality it will create a millions of partitions, but here for sake of simplicity I have divided it into 4 partitions. Partition A, B, E and F, and from each partition it will calculate a numerical value that is calculated from the RGB value of any color image, and or intensity of every pixels from black and white image. So it will put those values on functions where A, B, E and F are already obtained from images, and unknown variable are W, X, Y and Z. So for each set of images it will derive the equation, and the more set of images we have, the more equation it will generate, and the more accurate prediction can be done. So now the processor will process those functions to estimate the value of W, X, Y and Z. And while our processor is busy processing the value, let me tell you a fun fact about Snapchat that everyone use. Snapchat has been around since a lot, but it provides a feature of AR filter that provides some face masks through a camera. And while developing those systems in early 2015, the developer provide a large set of images containing face to those AI. And what they did was they manually select the face and fed it to AI. It's like AI look this is what a face look like, and they teach AI with every data set manually like that. And now that's why we are here with a very precise image detection, face detection in our cameras. Now our system has finished processing the value of W, X, Y and Z, which is obtained like that. And now we have unknown parameter A, B, E, F that is input from image. So to find if apple is present in that image or not, we have to again same partition on the next different image, and it will generate the value like this. And then to a function that we estimated earlier, we put place the value of A, B, E and F like that, and then those value can be calculated, and we finally obtain the value of F, which we have earlier estimated that it will be 70, but now it is obtained 65. There is little inaccuracy, but but it can be said that within a certain accuracy that this is an apple, there is an apple, and if their value will be a 6, will have been a 60, then there will have been a less chance that apple is contained in the image, and if that value will have been a 70, then our AI will be 100% sure that there is an apple. So another advantage of this type of system is that to share same functionality of detecting apple to other users, we don't have to share a whole line of code or whole mathematical algorithm or whole data set. We just can share this function, that small functions to other, that and other can use it to create or use it to detect an apple in their images. So everyone, please can you look at me? This is what our eyes sees me through our eyes, and this is what any camera lenses, a camera receptor sees me, and this is what a digital system sees me, like this in the form of pixels, and this is what AI sees me. This is how AI sees me in the form of numbers. Anyway, I don't look that bad in number, I think. Okay, let's change the slide, because I don't want any AI to fall in love with me. So, especially when there are a lot of beautiful faces I can see here for those things. So let's recap. So let's recap everything. So to make a system that is able to detect any object, we first have to train our model. We first have to provide a large set of images which contain that similar object so that we can create a function. And using those functions, we can identify those objects in the next very different images. And that's how AI has their own way of seeing things like us. Thank you.